Hey everybody, my name is Elric and welcome to another video on master data management in SQL, where we're essentially normalizing every single part of the system, the naming, databases, procedures, everything. Already have 2 videos up, about 30 minutes each, so in about an hour we created 64 databases and about 512 files to house our data. And before we create tables, we need to normalize the data that will go into these tables. So we're not really normalizing tables, we just don't want SQL data types like nvarchar and bigint inside of our system. We want to know exactly what the purpose is for that column. So we are going to define types for our system. Every time we add a user-defined type to our system, we also want to make sure that it is in every database. So we're going to tokenize a script and run it through all of our databases. And I'll go ahead and just get to it. You can follow along if you'd like, or just watch, either or. This is going to be fun. So the create type, if I could spell it correctly, syntax is pretty simple, and I'm just going to tokenize it right off the bat. Where we're just going to create type for a name that we're going to pass in and the SQL data type. We are also going to need to make sure that it's in the right one, and make sure it doesn't exist. Oh, come on. Let's grab this. Sys.types, where name equals, and this is going to be executed dynamically. So I'm just going to use my doubles now so I don't have to replace them. I'll wrap this in a begin end, format it. And that is our tokenized script that we are going to use, so pretty easy. Just go ahead and declare our variables for our tokens, and we have 4 of them. The database name, the database type name, the data point type name, and the SQL data type name. So we're going to remove name from the last one because it doesn't make sense. And I'm going to reorder these because I do want my types to be in every database in the system. So we're actually going to copy some of our code from previous scripts and paste it in here. Let me go ahead and just get my execute statements set up. My SQL scripts. This will be execute. Just get the internal parameters formatted. And I will set this Now I'm gonna open up the database script that we created in the first video. And I'm just gonna take all of this code. Actually, I'm gonna take all of this code so we don't have to write hardly anything. Which is really fun. I mean, I do enjoy programming, don't get me wrong. I love what I do. Sometimes we just want to see something happen. We don't want to code. Just want to create something. So I have my two incoming parameters, my cursor parameters, the scripts, base and execute, then all of the database types and database names in table variables for now, until we can create tables, and then we'll point them to that. And then I'm going to loop through the database and then the database type to make sure that my user-defined type is in every database and every database type. So this is where I'm going to replace my tokens. And I have 4 of them. Hey kitty. Yeah? Come here. Yeah. I have a database type name, database type key name. The data point type key name, and the SQL data type. I'm just going to move this down so you can see it's right in the center. Get this formatted so it looks good. And this is where we are replacing the base. The database name. I'm just going to copy these. Oh, maybe that wasn't the best, but that's okay. We have the database type. The data point type. And finally, the SQL data type. I'm gonna go check that token, make sure that's how I spelt it. SQL space data type. Excellent, that is. Alright, so we don't have any parameters declared. I'm just gonna go ahead and run this. Awesome. So no programmatic errors that I can see so far, but we are running dynamically executed code, so there's always that. But I do think that we are done with our procedure. So we declare variables, initialize variables. Begin database loop. Begin database type loop. Create user defined type. And database type loop. Loop. database loop. So I'm going to copy all this code and go back to where we store our code. I'm just going to modify one of these guys. So we already got everything filled out. Creates a user-defined type for every database in the system. And I'm just gonna replace this code. And the first thing I'm gonna do is change alter to create so I don't accidentally overwrite this. And this will be data point type. Because we're gonna come back and actually, when we get something passed in here, we're going to make sure it's in one of our tables because that's where it should go for storage. So I'm going to just name it accordingly. Awesome. So it looks good. We're just going to save this and refresh. And give it a try. So one of the data types that I need that I'm going to define, because essentially we're defining data in our system, I'm going to define the name, and the name is going to be an varchar 100. So let me go ahead and see if it created it. Did not, I believe. I know why. Let's see. Yep, did all that work replacing it, but we forgot to run it. Which is fine. No harm. And let's do alter. Let's try it again. There we go. So, just like everything else, we're going to be creating a ton of these. Try to get prepared for our next video on creating tables. Oh, don't want to do that. Just want to close the rest of them, but this. Awesome. I'm going to borrow a cursor. Here, I'm just going to save this as create data point types script. I might get rid of some stuff that I do not need. Database and database type are handled in that procedure. So I'm gonna remove the inner cursor, but I'm gonna leave the outer cursor because we're really consistent in how we name things. I should be able just to replace database with data point type. Yep. Repurposed my code. Very little typing. I'm just going to go ahead and give this one more column for our SQL data type. Then I'm just going to erase these and start creating types. I'll try to explain what these are used for in our system, because we're defining data that is in our tables, no longer am I going to go to a table and open it up and be like, what's this column? And it's just going to say varchar 100. That's what it is. But instead, I'm going to be able to go to a table and expand it and look at a column, and it's going to say UDT name. I'm going to think to myself, oh, that must be the name of the record. So that's where it's going to help us. I'm actually defining data, normalizing the data that we store. So the name is for the name of the record, and not for like a people first or last name. No, those won't be in the base people table. We'll have those in a different structure, and you'll see why. It's going to be really cool. The key name is for us to use in our code, so we're not referring to primary keys in our where clauses. I paste that. Yep. Let me add a column or comma and just copy it again. Actually, let me get some formatting on here too, so it's easier to read. And I have a description for every record in our system. Give it a 500 length. And I have an abbreviation at 50. Well, to go back a step, a description for every record in our system. That's why we're going to have a description, so we can look at a record and get some information. In the abbreviation too, in case I did refer to something, like some people refer to master data management as MDM, we want to have a column. It's going to be null most of the time, but just want to make sure that we're prepared for it. And I'll even have things like DB in some of my abbreviations and FS for things that I use in the system. After abbreviation, I'm going to create a column called header that I usually use for JSON going out. You kind of think of it like column headings, like in Excel. ABC, AA, ZZ, all that stuff. So we can do pivots off of this. And this is going to be in every table too. Actually, most of these columns will be in, most of these data types will have columns in every table. Next two, we want to define display orders. And sequences. Sequence being like a distance from a parent or child, or a priority. And a display order, just being what it says, order of display when we're querying it for use in like a drop-down list or for a screen or UI. Sorry. And now we're going to do some system columns that are going to be in every table. The primary key, obviously. A neat little feature in the system, the cleanse to, where we can reroute data that we no longer need to a different key within the same table. We'll need a foreign key, data type, and we're going to need a foreign key implied data type because our relationship table has a very unique structure, and the use of this will make sense in later videos. You're going to need several of these specific dataset numbers, essentially the table's unique identifier. Not GUID, but it is a integer. So every data set in our entire system, every table, every view, every Excel file that we refer to will have a unique ID. So we will always know what table a primary key refers to. And it'll help us with the physical modeling too. The specific dataset number implied is just like the foreign key implied for a relationship table that is not just one table joined another. It is a many-to-many on either side where they could be from any table in our system. So that's why we have the implied, so we can easily tell what is a foreign key relating to an actual table and what is a generic foreign key that we'll have to look for its corresponding specific dataset number. Then we're going to have specific dataset number source, which is where we generate this column. Then we're going to have some availability data types. So row active. Do we trust a row? A valid flag. And has the row or its children been removed? Archive flag. Next, system functionality columns. So we have a display database, and every record could have display data, so we want to make sure we have a flag that says this record does. And the same thing goes for time-based availability, development notes, and security. And actually, because we have the cleanse to, we actually want to create a flag to represent if we can't even clean it. So we can disable the cleaning process that will run in our quality database on data that we know is 100%. And that's going to help us always stay true to the data. Other columns that we will need in our system that will be in every table is a tenant ID, a taxonomy ID for our hierarchical relationships, our table shapes, and that is our next video, or my next video, table shapes. And for those hierarchy tables at the very top, they will not have taxonomy IDs, because taxonomy IDs just go one level up. They will have cluster groups to assist in physical modeling. And now we're just going to create data types for our procedures. Give it varchar. Give it, there we go. There. Okay. So all of our, we're not going to use nvarchar in our procedures anymore. Not after this. All of those, all of the data point types for our procedures will just begin with standard. We have a standard flag, standard integer, and I'll just copy paste this for standard numeric. Change this to float. Get this formatted. We will have standard date and date time. Okay. we'll have a standard text at 100 and standard dynamic SQL, which that's what our base and executes will. Those are those data types now. No longer will they be in varchar max, just the word, but they will actually have a definition. Same for JSON when we get there. Need a standard GUID. And I think that will do it for now. Flag, big int, float, dates. Got some in varchars and a unique identifier. So that is all that we're gonna do right now, and we're gonna save this script so we can just come in and uncomment these, so we have a quick, easy way to add more. Oh, look at that! I forgot to grab that execute and put it in here. That would have been good. Let's format this. Control-Shift-R. Oops. Awesome. That is why we do that. Duplicate this. Grab that variable. See, I almost forgot. There we go. Awesome. So, I'm gonna go ahead and run this. Clean this up a little bit, and actually I'm gonna save it, and then I'm gonna hit F5. Well, that's... sometimes that happens when we reuse code without fully going over it. That's okay. That's development. There we go. So that's going to create them all for the system. So what we did today was just got ready to start creating tables. We created 35 times 64 data types. I mean, 34 unique data types in every single one of our databases. So let's check to make sure that that worked. Oops. Come on. And it did. So we created all these types to prepare us for no longer using these things in our script. We'll actually be able to start using proper names. So we can tell exactly what a column is, even if we forget. We can just go to a table, go to some code and say, okay, this is just a string that's being used. And they'll have the same consistent precision. So that'll help us in normalizing data. So our next episode, we're going to actually start creating tables to start having these tables create other tables for us, because we are normalizing the entire process of spinning up a system. And I guess it's been about an hour and a half in videos, and we already have 64 databases, 200 plus files, and about 200 unique or user-defined data types defined. So we're doing pretty good for less than a day's worth of work. And yeah, if you have If you have any questions, just feel free to leave a comment below. And I will see you next time. Have a good one.